Sitefinity Cloud utilizes page precompilation, distributed output cache, and a content delivery network, or CDN, to significantly increase your website's performance. In this video, we'll review these components and see how they work together to speed up your site. Let's first review a typical page request in Sitefinity. This diagram shows a simplified version of the page request process. First, a user makes a request for a page with their browser. The Azure web app has the source code for Sitefinity and any static files like JavaScript, CSS, images, etc. Then, Sitefinity calls the database to fetch content that's stored in the database. This could be news items, blog posts, or any content stored in the database. The data is returned to the web server, where it's combined into the final HTML needed for the page. The final page HTML is then returned to the user in the browser. The slowest part of this process is typically calling the database to return data to the web server. Therefore, many of the performance optimization techniques try to reduce the amount of data that comes from the database when a page is requested. The first performance optimization technique is called page precompilation. Precompilation helps pages load faster when they're requested for the first time and reduces processor load. The Sitefinity application itself has had a precompilation tool for quite some time. Normally, this tool is run manually before deployment, but with Sitefinity Cloud, the precompilation step is integrated into the deployment process. When the precompilation tool runs, it's executed against the deployment slot on the environment where the deployment is happening. It queries the markup of the pages, compiles them, and stores the result in assemblies on the server. The assemblies don't store dynamic data, such as news, blog posts, or content from dynamic modules. When a user comes to the site and requests a page, Sitefinity will serve content from the assemblies if it can, or query the database for the needed dynamic data. A second performance optimization technique is the output cache. The output cache is a feature of the Sitefinity application itself. The output cache stores the final HTML needed to render a page in memory on the server. This reduces the number of calls that need to be made to the database. When a user requests a page, Sitefinity calls the database to return the content needed for the page. This final HTML content is stored on the server in the output cache. The next time the page is requested by any user, the page is delivered from the output cache and no database call is needed. The page remains in the output cache until it expires. This expiration might be based on a certain time frame or will occur when an admin user publishes a new version of the page from the Sitefinity backend. This process is called output cache invalidation. The output cache is a standard feature of the Sitefinity application itself. Sitefinity Cloud takes this one step further by introducing a distributed output cache. This distributed output cache is powered by Azure Redis. In the production environment, there are always at least 2 web apps running. When a user requests a page, they might hit any of the available web servers. Because of this, the output cache cannot be stored on a single server. It needs to be stored in a location that all websites can access. The first time a page is requested, the load balancer will send the user to a server, which will request the content from the database. The content will be returned to the web app, and the final HTML needed to render the page will be sent to the distributed output cache in Redis. The requested page will also be returned to the user. The next time the page is requested, Sitefinity will return the page from the distributed output cache instead of calling the database. All websites will have access to the same output cache, which will keep the content cached until a publishing event causes the output cache to be invalidated. Azure Cache for Redis also improves the performance after deployment, scale out, and unplanned restarts because instances do not have to build up the output cache on their own. For example, a new website instance, which has been added after scale out, can instantly start returning a cached response for a given page. As we've seen, the distributed output cache speeds up performance after a page has been added to the cache. But there still exists a problem. When the cache is invalidated, the next request to the page is relatively slow since Sitefinity has to go to the database to get new content. Sitefinity Cloud solves this problem with a new feature called Output Cache Warmup, which is configured with each instance of Sitefinity Cloud. When the distributed output cache is invalidated, Sitefinity itself will make a request for the new page and then cache the results. This is done through a background process which hides the performance hit from the end user. The old version of the page is displayed to the end user until the new version is cached. After the new version is cached, it's instantly displayed to the end user without decrease in performance. Let's see this in action. First, an administrative user makes a change and publishes a page in the Sitefinity backend. The publish triggers the distributed output cache to be invalidated. Sitefinity itself makes a request for the new page, pulling content from the database and then updating the cache. If a user visits the page before this process is completed, they will see the previous version of the content until the caching process is complete. Then the new version will be served instantly from the cache for future requests. The final performance optimization technique used by Sitefinity Cloud is the use of a Content Delivery Network, or CDN. Progress has selected the best-of-breed CDN, Cloudflare, for its performance, feature set, and ability to integrate with Sitefinity Cloud. In the previous video covering availability features, we learned that Sitefinity Cloud uses Cloudflare to store a cached version of the HTML that renders a page. Using this approach, the entire page and all its contents are served from an edge server closer to the user. Caching pages on the CDN level can drastically boost website performance, not only in terms of speed, but also when the website is under heavy traffic. Typically, when using a CDN, the CDN cache is refreshed only after the time to live expires. This does not allow for long CDN cache durations because website content can quickly become stale. In Sitefinity Cloud, to solve this problem, there's a workflow configured to proactively purge the CDN cache for specific URLs. This means every time a page is updated, the CDN cache is updated right away, with up to a few minutes delay. In addition, the CDN invalidation workflow is configured to work together with the output cache warmup. This means that when a page is updated, Sitefinity Cloud will first request the new page, ensure it's cached on the server, and only after that will send the purge request to the CDN. This ensures optimal website performance on all caching levels. Sitefinity supports complex cases using the CDN, such as A/B testing. Sitefinity Cloud automatically detects whether a page needs to be cached or not and provides the necessary cache control header values to inform the CDN what to do. For example, pages that have active A/B tests will not be cached on the CDN. Pages that have fully personalized versions for the whole page will also be excluded from the CDN cache. Pages that have personalization per widget will have CDN cache because the changes are applied client-side after the page is rendered. To conclude our discussion on performance, let's revisit the overall architecture diagram one more time. Cloudflare is used as a CDN, caching static pages on edge servers closer to the user. In the production environment, all the websites will use the distributed output cache to improve performance versus loading content from the database. If the distributed output cache is invalidated, a new version of the page will automatically be requested, stored in the output cache, and sent to Cloudflare. And by using the output cache warmup, users never experience a delay even when loading content that has just been updated. All of the components work together for optimal site performance. This video is one of a series of videos about Sitefinity Cloud. Make sure to check out the other videos to learn about the many benefits of Sitefinity Cloud.